In this video, we're going to discuss prime factorization using two methods. So let's discuss prime numbers first and what they are. Prime numbers are numbers that have exactly two factors, one and the number itself. And by the way, one is not a prime number, is neither prime nor composite because one only has one factor. So prime numbers have two factors. So let's talk about some prime numbers. The first prime number when we look at our whole numbers in order would be a 2. So 2 has two factors, one in itself. 3 would be the next prime number. 3 has two factors, 1 and 3. It doesn't have any other factors. 4 is not a prime number. Every even number after the number 2 is a composite number. So 2 is the only even prime number. So after 3, we have 5. 5 is a prime number because it has two factors, 1 and 5. And then 6 is not. 7 is a prime number. 9 is not a prime number because it has factors of 1, 3, and 9. So after 9, or after 7 would be 11, and then 13, and then 17, and then 19 and 23. Now, there are more prime numbers, but for our purposes today, what we'll probably be using the most of will be the first 4 prime numbers. We probably won't go any higher than 7. So our prime factorization will use 2, 3, 5, and 7 most likely. We could possibly get to an 11, but I doubt it. So let's talk about prime factorization and why we use it. Prime factorization of a number can be used in finding the greatest common factor and the least common multiple. I typically will list out factors and multiples to find GCF and LCM, but it can be used in either one of those processes. Also, we use prime factorization when we simplify fractions. One of the methods is using prime factorization. So let's talk about the two methods to find prime factors or prime factorization of a number. One is factor trees. The other one is what I call upside down division or repeated division, and I'll get to that in a minute. Let's talk about factor trees. Okay, so if I said find the prime factorization of the number 12, what we're going to do is we're just going to find one factor pair for 12 and then go from there. It can be any factor pair. I usually like to use the factor pair that is the numbers that are closest to each other, like 3 times 4. So I'll do 3 times 4. Now, 3 is a prime number, so that number I will keep the same, but the 4 has to be broken down again because it's not a prime number. So any numbers that are composite numbers, you're going to create another 2 branches under that number. If it's a prime number, though, it's just going to get 1 branch and it's just going to come down to the next line. So 3 times, and then 4 will be broken down into 2 times 2. Now, all I have left are prime numbers. So each of these numbers is prime. 2, 2, and 3, or yeah, 2, 2, and 3 are prime. So I have the prime factorization for the number 12. What I want to do is I want to rewrite it in order from least to greatest number. So I'm going to rewrite it as 2 times 2 times 3. So this is the prime factorization for 12. And no matter how you did this, if you did 2 times 6, you don't want to do 1 times 12. You don't want to use 1 because 1's not prime nor composite. So you want to end up with prime numbers. So, but no matter what factor pair you use that's not 1 times 12, it would still work out the same way. Let's try another one. Let's do 36. Okay, so I'm going to start with 2 branches, and I need a factor pair for 36. I'm going to do 6 times 6. Okay, neither of these is prime. If one of them was prime, it would get 1 branch, but neither of these is prime. So I need to do 2 branches per number, and then I'm going to create another factor pair for 6. A factor pair for 6 is 2 times 3. And then I want to times in between that, and the factor pair for 6 again, 2 times 3. There's no other factor pair I could use for 6 because 1 times 6 has 1 in it. It's not prime. So the prime factorization for the number 36, I'm going to put these in order, is 2 times 2 times 3 times 3. So this is the prime factorization for the number 36. We'll do one more. Let's do 32. Okay, so factor pair for 32. Let's go with 2 times 16. Okay, so 2 is prime. So I'm going to make 1 branch from the 2 and bring it down. And then the 16, I'll do 4 times 4 this time. 2 is still prime. Let's just bring it down with 1 branch. The 4s are each composite, so they will each get 2 branches, and I need a factor pair for 4. The factor pair I'm going to use for 4, and it's the only one I can use, is 2 times 2. And then this other 4 is also going to be 2 times 2. Okay, so I'm left with all prime numbers here, and they're all 2s. And so the prime factorization for 32 is 2 times 2 times 2 times 2 times 2. And eventually you'll use exponents, but we're not going to worry about that today. All right, so let's look at another method. I don't know what you call this method, but I call it upside down division because that's kind of what it looks like. So let's take those same numbers. Let's start with the 12. We'll take a 12, and what I want to do is I want to just write the 12, and I want to write draw what looks like an upside down division symbol. So instead of writing it like this, I'm going to do it the other way, upside down. I want to divide 12 by the smallest prime number that I can divide it by. Well, if it's an even number, so the smallest prime number, the lowest prime number that I can divide by would be 2. Okay, and then I'm just going to do that division. 12 divided by 2 is 6, and I'm going to write it up there. If I have a prime number here, then I leave it alone. I'm done. I don't have a prime number. 6 is still an even number. As long as I keep getting even numbers, I need to keep dividing by 2. So I'm going to divide by 2 again. 6 divided by 2 is 3. Now I have a prime number at the bottom, so I know I'm finished with my prime factorization. My prime factorization is just right here, 2 times 2 times 3, 2 times 2 times 3. So it shows up in order, if you do this correctly, it shows up in order down the left side. So the prime factorization for 12 is 2 times 2 times 3. Let's try 18. So again, I want to start with the lowest prime number I can. If this is an even number, I'm always going to put a 2 here. 18 divided by 2 is 9. Okay, now I don't have an even number anymore, but it's also not a prime number. Because you remember our first few prime numbers were 2, 3, 5, 7, 11. So the next prime number up is 3. 3 will divide into 9. So let's draw another upside down division. Divide by 3. 9 divided by 3 is 3. 3 is in these prime numbers. So I'm finished with my prime factorization. My prime factorization for 18 is 2 times 3 times 3. Let's do one more. Let's do 42. It's an even number. The lowest prime number I can divide by is 2. As long as it's an even number, keep dividing by 2. 42 divided by 2 is 21. Okay, so 21 is not an even number, but the next one I can divide by is 3. So let's divide this by 3. 21 divided by 3 is 7. 7's a prime number. So I have my prime factorization for 42. 2 times 3 times 7. And so that's 2 methods for finding the prime factorization. This one's actually my favorite. This is the one I like to teach my students. But you can also use factor trees, so factor trees and repeated division.